Hello everyone, welcome back to the channel. Today we'll try to secure our GWT token using data protection API. Now let's implement this crypto service, a new folder, let's call it crypto. Under crypto, create a new interface, call it iCrypto service. The first function that we have to define is to protect and save the data or the sensitive information locally in our computer. Next function that we have to define is to retrieve and to load the data. I would like to add some more two helper functions here to delete the protected file once the user has logged out completely from the application, and to check if this particular file first of all exists to simulate session. Now we have to provide the implementation that's going to be used under a normal environment. So this class will implement secure file encryption and decryption and management using Windows Data Protection API. We will use the cryptography namespace. It's going to implement iCrypto service, implement all members. Let's start with this function, protect and save. Will encrypt a plain text string and securely writes it to the disk with the current user scope to bind the encryption key to the logged in user account. This is my current user. It's going to be related to this one. First of all, what we have to do here, we need to get the user's application data path. Now we got the application data folder. Now we have to build a secure path. Like for example, if your partition is C, we're going to do something like C and users and the name of the user and the application data and roaming and application name and file name, for example. We're going to combine basically those two paths. The first one is the application data folder and the application name and the file name that we're going to use under the protect and save. We need the application name. Let's not hard code this. I'm going to create it as a private function. We can get the application name dynamically by using assembly, get executing assembly and get name. And because it's nullable, we have to do here a fallback value from the constant file. Let's call the constant file and more specifically the application name. I think it's going to be just a computer property, to be honest. Application name and the file name. Next, we have to encrypt the data using the data protection API. This function is going to give us a byte array. Protected data, protect. The first parameter that we have to use is to convert text to byte using UTF encoding. And it's correct from the suggestion. Next, going to set null as an optional entropy, and we have to limit access to the current Windows user by doing data protection scope and current user. Next, we have to ensure that the directory exists before saving the file. We can access it from using path and get directory name by passing the file name. Otherwise, I'm going to throw an exception saying, for example, enable to read directory information. Next, we have to create the folder if not already existing by doing directory and create directory and passing as an argument directory. And finally, we're going to write the encrypted data to the file as a binary bytes by doing file and write all bytes as shown here, which is correct, by passing as an argument the file path as well as the encrypted data. And basically that's all we have for to encrypt the data. This is a simple implementation for our tutorial. You can add more guard statements here and there to even make it more robust and more secure. Now let's try to decrypt this sensitive information. We're going to decrypt and retrieves the original plain text from the encrypted file. Instead of using protect, we're going to use unprotect from protect data class. We need to locate the file in the user's app directory or app data. Next, we're going to store the file path by combining the application data folder, application name and file name as shown here from the suggestion, which is very helpful. Next, we're gonna make sure that the file exists. If it does not exist, we're gonna throw an exception, file not found exception, as shown here, which is very helpful. Afterward, we have to read the encrypted bytes from the file. We're gonna store this under byte array, as shown here, which is very helpful. Thank you very much. Encrypted data, file and read all bytes and providing as an argument file path. Next, we have to decrypt the data using the data protection API by calling from the class protected data and protect, which is very good. So far, so good. At the end, we have to convert decrypted bytes back into the readable UTF-8 string. This is magical, to be honest. This is exactly what I want to do, which is very good. This is very helpful under Visual Studio. Next, we're going to combine, basically, as we have done earlier, as shown here, file path, by combining the three paths: application data, folder, application name, and file name. And we will do file and delete the file. You can do it like this, as shown here, but I would like to keep it with exception handling by doing delete. And it's going to propagate basically the exception. If we ever have an exception, it's going to be propagated to the higher level handling parent. Now let's implement the last function, which is to check if we have the protected file. As usual, gonna get the application data folder, get the file path, and return file exists. And here we're going to return file exists file path. That's pretty much it for the implementation of crypto service. Nothing substantial. The main thing here is we have to limit the scope for the current user to not allow other users to decrypt basically this sensitive information, which is the GWT token. Now we have to move to the other implementation that we have to do, which is for the dispatchers. For dispatchers, we need to provide a reusable dispatcher in testing as well as in a normal environment. And since we are going to deal with view models, we have to call the methods invoke and invoke async. For a normal environment, those methods going to work fine, but under testing, it's going to cause problems. Therefore, we have to create an interface that's going to be reused in different scenarios under testing and under normal environments. The dedicated implementation for a normal environment will be provided accordingly, and the dedicated implementation for testing, it's going to be implemented and provided accordingly. I'm going to create under util package a new folder. I'm going to call it dispatcher. Under dispatcher, create a new interface. Let's call it iDispatcher. As I said before, going to deal with the invoke method and pass here an action as a parameter and the invoke async version. Now let's provide the default implementation for this dispatcher in a normal environment. For the implementation, it is very simple. We have to use application and current dispatcher invoke and action. This is how you normally would call this invoke method under the view model. With the same manner, I'm going to copy this for the async version, invoke async. As simple as this. Now the last thing that we have to do under this video is to implement a reusable class. It's going to be an extension on the observable validator. And if you are familiar with the community toolkit, we're going to use the observable validator under the login form as well as the register form. And the need of this particular extension is to satisfy the state hoisting principle, because state hoisting principle can be problematic here under WPF. We're going to proceed with state hoisting in order to maintain the reactivity of the forms, whether the form is valid and the field is valid or not. We have to implement something that's going to keep the binding works as expected under the view or the example file. Hence this extension function on observable validator extension. It's going to be a method for observable validator to make it easier for us to work with the result of the validation under the observable validator. The name of the function, it's going to be called getValidationErrorMessage. It's going to give us a string, a nullable string. This method is going to retrieve, as I said before, the first non-empty validation error message for a given property name. The first parameter that we have to pass here, which is this, to use the extension function. The object on which we're going to apply this extension function, it's going to be applied on this, which is of type observable validator from community toolkit. Hence, we have imported in the beginning of the video the dependency or the package community toolkit. And the next parameter, it's going to be the property name. To do this, we're going to return from the view model the errors by calling getErrors, which is a built-in method. This is going to give us all the validation rules and even the custom ones. Next, we have to convert the collection to a sequence of validation results objects. Why we do this? Because we only care about the validation result types which have an error message property. By doing because it's nullable, we have to use this null safety operator and to call of type validation result. And you have to select just the error message strings from each validation result by calling select e for error and e.error message. I'm going to return the first error message that is not empty or white space. Because it could be multiple validation messages, we only need the first visible one. I think for this kind of scenario, it's more than enough. And that's about it for today's video. For the next video, we're going to implement the mock-in of our services. I hope you have learned something new. See you in the next one, and happy coding!